Row, row, row your boat gently down the stream. Merrily, 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 life is but a dream. Yep, no budget for theme song, so that is it. My name is Ohan, and this is Apes and Drapes. This episode is brought to you by Brodmann's Brain Regions numbers 44 and 45. Yes, it's Broca's area, everyone's favorite language center in the inferior frontal gyrus, bringing you my capacity to form words. It's Broca's area, open 24/7 even on holidays, and conveniently located in your brain. Alright, here we go. The brain is really good at storing instances of objects, scenes, and ideas. Let's look at what that means. And no, I'm not talking about the brain because the brain regions are our sponsor this week. I promise I was going to have done this anyway. The brain takes in data from the senses. There are different cells in each sense organ that receive the flow of stimulus and communicate it through various channels to the specific neurons, which then filter the data through the brain to make sense of it all and create a coherent representation of what we call reality. That reality is your experience of the universe from within and as a part of the universe. Aside from the specific parts of the brain that are responsible for putting this information together, there are also parts that make sense of the information by comparing it seemingly instantaneously against everything the brain has seen before and relating it to the memories that match. Okay, now let's pause to take a crash course in brain anatomy in just a few sentences so we're all on the same page. Let's build a brain. First, think of a little oddly shaped ball, and making up that ball are many parts, some of which you might have heard of, like the amygdala and the thalamus. This is the inner part of the brain, and it's where all the interesting stuff happens in my opinion, but that's for another time. Now, think of a very thick, meaty shell on either side of the inner brain moving in and encasing it. This is your cortex, which has a left and a right hemisphere. This is what people are talking about when they mention left versus right brain. Each hemisphere is cut into 4 lobes: the frontal lobe in front, the parietal lobe on top, the temporal lobe on either side, and the occipital lobe in the back. This whole thing, the cortex plus the inner part of the brain, is the cerebrum. Now, attached beneath the back third of the cerebrum is the cerebellum. The cerebrum makes up 85% of the brain's weight, whereas the cerebellum makes up 10%, but they each have 50% of the brain's neurons. Curious. The cerebellum has a couple of parts as well, but is more of a cohesive cauliflower-looking mass and operates kind of like a modular second brain, doing a lot of necessary things, but in a very mysterious way. So when we're talking about the brain, and really whenever you hear or read about it, you're likely hearing about the cerebrum, meaning the cortex and its 4 lobes and all the exciting bits in the inner brain, even though, like a creepy friend or supportive relative, depending on which view you want to take, the cerebellum is always involved. And I also want to throw a quick shout out to the brainstem and a crucial component called the pons that acts as an important relay center for a lot of communications. And we've built our brain. Good job, everyone. That was easy enough. To recap, my brain sent my brain's image of a brain broken into sound waves across time and space with the help of machines into your brain so your brain could understand what it itself looks like. Pretty fucking amazing. Now, let's bring it back. Your brain took that sound in as sense data. That sense data went in through your ears, then straight into the inner brain, which pushed it out to the temporal lobe, then over to the frontal lobe, and just like that, you're aware of it. That's an oversimplification, but close enough to get the main gist. So, another example of stimulus is the light that hits your eye. It goes through a whole series of filters in the eye itself, thanks to the retina, before sending it off to the brain. The retina is the back wall of your eye, which is essentially a concave surface. This is a really curious thing about sight. The world around us is 3-dimensional, but the retina which receives the data is a curved 2-dimensional surface, and yet we have a 3-dimensional representation of the world. The brain, because it has 2 eyes to use, even though it seems like the distance between them isn't very much, superimposes both 2-dimensional images, one from each eye, and compares the differences between them to guess at what the 3-dimensional world that is providing the data might look like. This is called the parallax effect, and we use it to do a similar thing when taking pictures of the universe by pointing multiple telescopes at the same part of space to have a more accurate guess as to what we're looking at. Now, the details of the eye are just really cool. They aren't necessarily relevant to the categories conversation, which, yes, we are still having. We're just a couple of layers deep in at the moment, but the parallax concept, meaning adding a dimension to understanding by comparing 2 perspectives, is a fantastic concept to apply to ideas. But I'm going to table that first to say this. The more categories we have for things, the less ignorant we are about the world around us. Every instance of everything deserves its own category if we are to deal with reality in a way which is consistent with how reality actually presents itself to us. But because of the fact that we live for such a short amount of time, relative to how much information we come across, we use a crucial shortcut. We categorize everything we come across so that we can process it more quickly and move on with the rest of our environment. This is a crucial ability in a reality where physical threats are constant. But in this manicured version of contemporary reality humanity has created for itself, we've adapted the ability of categorization to help us to better consider future outcomes in a way that saves us time. The process of categorization has evolved with us. I can lump any two things into a group or distinguish them as being from two different groups based on how I want to interpret them or how I want them to be interpreted. I can look at an apple and a tomato, and I can build a framework in which they're practically the same thing or in which they are two completely different things. William James, the philosopher considered to be the father of American psychology, summed it up with this one brilliant sentence: "There are no differences but differences of degree among different degrees of difference and no difference." I'll repeat that. There are no differences but differences of degree among different degrees of difference and no difference. Possibly the most linguistically fractal statement ever made. Basically, all differences that we perceive between two things can be perpetually subdivided, but really all information is generated by humans. All differences are human-made differences of degree, and there's no real difference between them. Categories are useful for understanding our realities, but they have to simultaneously be both well-defined, so we know what we're talking about, and fluid, so that we can continue to always take in more information. We can zoom in or out of the differences between things based on how it suits us. Earlier, we built the brain by zooming out. Now let's quickly do it by zooming in. The brain has two parts, the cerebrum and the cerebellum. Zoom into the cerebrum, and you've got the cortex and the inner brain. Zoom into the inner brain, and you've got, among other things, the amygdala and the thalamus. Zoom back out to the cerebrum level, and then zoom into the cortex, and you've got the four lobes: frontal, parietal, temporal, and occipital. By reinforcing our categories, we can build a better mental map of them. The brain should be in a category with the spinal cord, called the nervous system. The nervous system might be in a category called body or anatomy, and so on. And because I can't resist, the sponsor of this episode, one of the primary speech centers called Broca's area, is found by zooming in like this: the body, the nervous system, the brain, the cerebrum, the cortex, the left hemisphere, the frontal lobe, and there we find Broca's area. The human mind relies on categories to process information. All of the things we know of are abstracted into ideas. Every word is an abstraction of either a physical thing or a concept so we can process and speak of it. Most people have not seen a physical brain, so even though we have one, our ideas of a brain are abstract. Even less people have seen a brain being taken out of a skull. We just all trust that that is where brains are. Once we process a word, we put that word into a category. The more categories we create, the more we are able to accept change and nuance. The ability to create new categories for every instance of a thing is to retain an open mind. The fluidity of category creation and recategorization is open-mindedness, and the capacity to understand subtle differences between categories and that no category has a rigid boundary is nuance. The more the type of a thing we experience, the more we are willing to have a blurred line for a category. If we'd only seen large, round, red, sweet apples, we would assume all apples had those attributes. The first time we see a small, ripe apple, we can either assume that there's a category of apples which are smaller, or accept that a small apple is an exception to our normal concept of apple. The more types of apples we experience, ones that are green or bitter or oddly shaped, the more subcategories of apple we will create in our minds, or the more exceptions we will accept. If we experience enough apples, we can expand out consistencies between categories of apples, but still have an overarching category of apple. If we experience no consistency between apples, then we won't have any subcategories. We will just have one nebulous category that will be representative of a structureless appley chaos. If we then experience a pear crossed with an apple, let's call it a papple, the lines between the categories will be blurred. At that point, we either have to restructure the lines of our category, or accept that two categories have a blurred line, or just create a new category for papples. Basically, when introduced to an instance of a thing, we create a category. It only takes a couple of similar examples to reinforce the idea enough for us to create a passive dogma out of that category. If we then experience one counterexample, we will likely make an exception for that counterexample. But if we experience several counterexamples, then we are likely to make a new category or categories to hold them. There's a knee-jerk reaction that some people have to the idea of building out more categories. as though breaking down all walls were possible, and that really the ideal was to not have more categories but less. The only way that might be achieved is to have one category for every instance of everything. The less categories one has, the more likely one is to generalize. To be able to avoid generalization, we need to build out more categories which include variations and alternate instances of types of things, and also allow for overlaps between different categories and between the subgroups of different categories. It's important to retain a fluidity for individual instances of anything. Rigidity is what causes us to stagnate in terms of our understanding of things. We have to allow room for things to change and for our understanding of things to change and develop. It's useful for categories to have clearly defined boundaries so that we know what they are, but for the categorizations to not be rigid. We have to allow for everything that falls into a category to do so on a gradient, but still have to define points on the gradient so that we know how to understand the gradient itself. If there are enough things that fall outside of the range of a category, we have to either alter our understanding of the category or create a new one to be able to accommodate the added instances of things. Categories are useful for understanding our realities, but are only as useful as they are simultaneously both well-defined and fluid. Which gets us back to the William James quote, "There are no differences, but differences of degree among different degrees of difference, and no difference." Everything falls on a gradient, even gradients.